Okay, today we're looking at transforming equations from standard form to vertex form. So here on your notes page, you'll see standard form, which we've seen before, ax squared plus bx plus c. Okay, and we need to transform the equation into vertex form. Okay, so we're going to do that by using completing the square. So when we start graphing these, we're going to want these equations in vertex form because the vertex of our parabola is going to be at hk. The x and y values of your vertex are going to be h and k. So that's why we want it to look like this, vertex form, so we can easily look at this and tell what the vertex is going to be. Okay. We'll also be able to tell what our axis of symmetry is. That invisible line that cuts our parabola in half is our axis of symmetry. Okay, and that's going to be whatever the h value is. Okay, and then we'll look at our a value out front. If it's a positive, if the a value is greater than 0, a positive number, then your parabola is going to open upwards. If the a value, the number out front of your parentheses, is a negative number, if the a is less than 0, a negative number, your parabola is going to open downwards. So here are the steps we're going to use. Okay, we need to make sure that our equation is written in standard form. Okay, we're going to group the first two terms together and we're going to separate the third term, kind of like we did with completing the square. We need to move that third term and we need to make room for our blank spaces. Factor out the a value of the first and second terms if possible. Okay, that's kind of like what we did before we fill in our blank space. We need to make sure that our a value is a 1. So we're going to take the GCF of those first two terms so we can make sure our a value is a 1 before we fill in those blanks. Then we're going to complete the square so we can fill in the blanks. All right, and then we're going to rewrite our equation to where it's in vertex form. So let's look at some examples here. All right, so our equation here is in standard form. All right, so the first thing we're going to need to do, we're not going to move this constant over, we're just going to separate it so we have room for our blank space. So I'm going to move my plus 8 to the back. Okay, and so now what I need to do is I need to put these first three terms in parentheses. Now if I put a blank space, there's two ways we can do it. Okay, we can either put another blank space at the end of our 8, or if we didn't put it here, we could also put the blank space over here with our y to the left side of the equation. But if you fill in a blank space on the left side of the equation, eventually you're going to have to move it back over here to the right side of the equation to get the y by itself. So sometimes it's just easier to put your blank space where it needs to end up. So we already know the shortcut to filling in the blank space. We take half the middle term, half of 6 is 3, and we need to square that. So that's going to be a positive 9. Now, this is a little bit different from completing the square that we did in the past, because here we're putting, if both of our blank spaces are on the same side, then they need to be opposite of each other. If this is a positive 9, this one needs to be a negative 9. Okay? The reason why, in the past, when we put a positive 9 on one side of the equation, and we've had to balance it out and put a positive 9 on the other side of the equation, if this had a positive 9 over here with my y plus 9, I'd have to move my plus 9 back to the other side. How? By subtracting it. So we might as well just put it there to begin with. Now, we know the shortcut for our factoring here. Just like with completing the square, I have to have an x in the front. So if I'm factoring this trinomial, half of 6 is 3. Positive 3, that's the number that goes in the parenthesis there. And then you just combine your like terms here at the end. 8 minus 9, you get a negative 1. And now we are in standard form. We don't have to solve for x. We just need to, we're in vertex form. We just need to write it in vertex form. So vertex form, x plus 3 squared minus 1. So again, if we're looking at our h and our k, all right, we are identifying the vertex or the parabola, the vertex of the parabola. The vertex here, remember, inside the parentheses is always going to be the opposite of what you see. You're going to do the opposite of what your x tells you. So my vertex is actually going to be negative 3. And then with the y value of my vertex, this is not the opposite. This is what it says it is, negative 1. So my vertex is going to be negative 3, negative 1. The axis of symmetry, that invisible line that's going to cut our parabola in half, always needs to be x equals. Always needs to be x equals. And so it's always the x value of my vertex. the x value of my vertex is -3. So that's the axis of symmetry. X equals -3. It's going to be a vertical line straight up and down, cutting through the x-axis at what number? Cutting through the x-axis at -3. Finally, the direction that we're opening. Remember, we look at the a value out in front of the parenthesis. Well, if there's not a number here, it's actually an invisible 1. So there's an invisible +1 out front. Since it's positive, then the direction is opening up. If this was a negative number out in front of the parenthesis, then our direction would be opening down. Another one, number 2 here. All right, so we're going to do the same thing. Y equals x squared plus 2x. Move your -12, your constant, to the back, so you have room for your blank space. Okay, so I'm going to go ahead and put both blank spaces on the same side of the equal sign. All right, we do have a 1 in front of our x squared, so we're ready to fill in the blank. So 2 steps. Half the middle number, so half of 2 is 1, but then we have to square that. 1 times 1 is still 1. Okay, now since I put a +1 in this blank space, since the other blank space is on the same side of the equal sign, you got to balance it out. So if that's a +1, then this one needs to be a -1. All right. Next step. What's the shortcut here to factoring this trinomial? I know it's going to be an x in the front. I know I have to have a squared at the end. Half of my middle number, half of +2, is +1. That's what goes in the parenthesis there. And then when you combine these like terms at the end, -12 minus 1 more, you get -13. That is vertex form. Y equals x plus 1 squared minus 13. So my vertex, remember I need an x and a y value. The x is always opposite. Okay, you're always opposite of what your x says. So we're -1 for our x value and -13 for our y value. The axis of symmetry is always going to be x equals. What number do we need there? It's always the x value of the vertex. So here it's x equals -1 because that's the x value of my vertex. And if you look at the a value, whatever number is out in front of the parenthesis, again, there's no number, so it's an invisible +1. Since it's a positive number, that tells us that we open up. Another example. Y equals, we got x squared minus 10x. Move your -4 on back. Leave your room for your blank space. Those first 3 terms need to go in parentheses. All right, let's fill in the blank. I have a 1 in front of my x squared, so I'm ready to fill in the blank. Half of -10 is -5. When I square that, -5 times -5 is +25. Since I put a +25 in this blank, I have to put a -25 in the other blank, since they're on the same side of the equation. All right, so ignore those back constants. Let's factor the trinomial here. There's a shortcut we always use. I know I need an x in front. What number is going to go in here? Half of my middle term, so half of -10, which is -5. Now combine your like terms here in the back. -4 minus 25 more, -29. So y equals x minus 5 squared minus 29. The vertex, the x value is always opposite, so it's +5. And the y value always is what it is, -29. The axis of symmetry always has to say x equals. And so the x value of my vertex was 5. And the last thing, which direction do we open? There's an invisible 1 out front again, a positive, so that tells us that our graph opens upward. And I'm running out of time, so I'll probably make another video to do an example problem on our assignment.